I want you to try and hold two completely contrasting realities in your mind at the exact same time.
Which is honestly a pretty big ask right out of the gate.
Right. But just stick with me. So on one hand, you have these eye-watering, just almost incomprehensible corporate expenses. I'm talking about burning through cash at a rate that would bankrupt most sovereign nations.
Yeah, absolute staggering sums of money.
Exactly. And then on the other hand, you have sudden, massive, highly scalable profitability.
It's wild.
It really is. Welcome to today's deep dive. We have a fresh stack of financial documents, daily briefings, research articles, all that good stuff.
And our mission today is pretty straightforward, actually.
Yeah, we're looking at the exact moment the AI business model is basically maturing from this, speculative hype cycle into real scalable financial accountability.
While also, and this is crucial, looking at the deep fragility of the physical world where all of this intelligence actually lives.
Right. So let's just drop the staggering number right away. Right now, one company is currently burning through $1.25 billion a month just to rent computing power.
A month.
A month. And yet somehow they are about to post a profit years ahead of schedule.
It's a completely counterintuitive dynamic because when you look at the sources we're pulling from today, we're seeing an industry that has decidedly moved past the question of whether things are changing.
Right, that's old news.
Exactly. Now it is entirely focused on how fast. We are watching the underlying economics of artificial intelligence just flip. It's going from an experimental research expense into a sustainable utility-scale business model.
Okay, let's unpack this $1.25 billion monthly burn rate because the sheer scale of that number is just, it's wild.
Oh, totally.
And we actually only know about this because of a leak, right? Like an IPO filing.
Yeah, SpaceX filed their prospectus and it accidentally gave us this massive window into the infrastructure costs of frontier AI.
Which is amazing. So Anthropic is paying SpaceX.
Right, Anthropic is locked into a $45 billion contract. They are paying SpaceX that $1.25 billion every single month for GPU compute access through May 2029.
They are essentially paying rent for the machines that think.
That's a great way to put it. It is the clearest public window we've ever had into what it actually costs to train and serve frontier models at this level.
And you would think a monthly bill of $1.25 billion would be, a death knell for profitability. It sounds completely unsustainable.
It sounds like a fast track to bankruptcy. But the financial documents show Anthropic expects their Q2 2026 revenue to hit $10.9 billion.
Wow. Which is a 130% jump from just their first quarter, where they pulled in $4.8 billion.
Exactly. And from that $10.9 billion, they are projecting an operating income of $559 million.
So they're actually making money.
Right. This is their first profitable quarter, and it is arriving years ahead of their own 2028 guidance.
That's insane. And we actually have a second major data point confirming this financial maturation rate.
Yes. OpenAI is reportedly preparing a confidential S-1 registration statement with the SEC.
Oh, wow. So they're going public.
It looks like it. And they are targeting a valuation of $800 billion.
Hold on, the math isn't mathing for me here, because our sources also mention this undercurrent of market anxiety. There's this fear that falling AI model costs could compress OpenAI's $800 billion valuation ambitions.
Right, because the cost of intelligence is plummeting.
Exactly. So if you're selling a product that is getting drastically cheaper every single month, you don't magically post a $559 million profit unless something crazy is happening. Is the demand really scaling that fast?
It really is.
Or is this just like creative accounting? How can prices be falling while revenue is exploding?
What's fascinating here is that the mechanism driving this isn't creative accounting at all. It's a classic economic concept called the Jevons paradox.
Okay, remind me how that works.
We see it all the time with energy. So AI compute costs are dropping by roughly a factor of 10 every single year. But when you drop the cost of a utility that dramatically, you don't just make the existing use cases cheaper for your current customers.
You unlock new ones.
Exactly. You unlock a tidal wave of entirely new, wider use cases that were previously economically unviable.
Okay, so it's kind of like data plans on our phones.
Oh, that's a good comparison, yeah.
Like when 4G and 5G made cellular data 10 times cheaper, I didn't end up saving money on my phone bill. I just started streaming 4K video all day instead of, sending text messages.
Right. You spent the same amount, but you consumed vastly more volume.
Exactly.
That is the perfect analogy. You made up for the lower price per megabyte with exponentially higher volume. And that is exactly what developers and enterprise clients are doing with AI right now.
The infrastructure is becoming a utility grid.
Yes, if electricity suddenly being 10 times cheaper, power companies wouldn't go bankrupt. The world would just build entirely new industries that consumed vastly more power.
That makes so much sense.
So the OpenAI S1 filing and Anthropic's early profitability, they represent the exact moment this industry is proving that the volume of demand vastly outpaces the falling cost of the supply.
Which explains why this maturation isn't just happening at the base infrastructure level. The application layer, like the ecosystem that plugs into this grid, is exploding with capital. And it's actually forcing entirely new hardware paradigms to support that volume.
Oh, the hardware shift is massive right now.
Yeah, for example, NVIDIA is now identifying a $200 billion market opportunity in CPUs that are specifically designed for AI agent workloads.
Which is a huge architectural pivot for them. Because for years, the entire narrative around AI hardware has been dominated by GPUs.
Right, the graphics processing units.
Yeah, those chips are built for parallel processing,
Yeah.
doing millions of simple mathematical operations simultaneously, which is exactly what you need to train a massive neural network.
But NVIDIA is recognizing that the workload is shifting now.
Right. As AI moves from a chatbot you occasionally query into autonomous agents that run continuously in the background, the compute bottleneck changes entirely.
Okay, I'm trying to visualize this shift in the hardware. So if the GPUs are basically the brute force muscle, like doing the heavy lifting to train the model, then for an agent that just sits in the background orchestrating tasks and making decisions, a CPU is more like the nervous system.
That's a great way to think about it. Think about what an autonomous agent actually has to do. It isn't just generating text. It requires complex orchestration.
Like remembering things.
Exactly. An agent has to manage persistent memory, decide which external tools to call, and handle complex multi-step branching logic over long periods of time. That is inherently a CPU workload.
Because it's sequential.
Right. A CPU is designed for sequential logic and managing system state, whereas a GPU is designed for parallel throughput. So the fact that NVIDIA sees a $200 billion market here tells us they expect the agentic layer to become ubiquitous.
And the venture capital ecosystem is clearly betting on that exact same transition. I mean, we're seeing companies like Hark raising an astonishing $700 million Series A.
For an undisclosed project.
Right, an undisclosed AI project. Investors do not throw $700 million at early-stage application layers unless they believe the foundational utility layer is stable enough to build empires on top of.
Exactly. And we are seeing that stability translate into highly integrated consumer tools, too. Just look at what OpenAI is doing with ChatGPT Pro.
The personal finance stuff?
Yeah. They are launching personal finance tools directly inside the interface. You can connect your bank accounts, build budgets natively. They are aggressively pushing the product away from being just a conversational novelty and turning it into a persistent personal operating system.
It's moving from a tool you visit to an environment you live in.
Exactly.
And it extends to the publisher and enterprise level, too. Our stack of sources highlights these new tools like Hit Publish, which basically allows for one-step generation and publishing directly to a CMS like WordPress.
It completely bypasses that manual copy-paste workflow we've all been stuck in.
It's so tedious. But the tool that really caught my eye in the sources is Recall V2.
Oh, yeah. The knowledge management space is seeing some of the most practical applications of this mature infrastructure.
It's incredible. So Recall V2 is a personal knowledge base, but it structurally addresses the hallucination problem.
Which is huge.
Right. The AI only searches the specific sources you provide in your library. It's not pinging the open internet and just guessing at answers. It's constrained. I assume it's using some sort of heavily restricted vector database to force the model to only pull from user-uploaded embeddings.
Yeah, it relies on a very tight retrieval augmented generation pipeline, or RAG. By constraining the vector space to only your specific documents, the model isn't trying to generate truth from its pre-trained wakes.
It's just reading what you gave it.
Exactly. It's simply acting as a reasoning engine over your verified data. It perfectly illustrates how the market is demanding applied, reliable, integrated tools rather than just raw conversational novelty.
But as this technology becomes an everyday utility, the American frontier labs aren't the only ones driving these economics down.
Not even close.
Which brings us to a massive shift happening on the global stage right now. The surge of Chinese open-weight models is aggressively taking over developer usage.
Yeah, the numbers on this are crazy.
Right. Ali Ghodsi, the CEO of Databricks, reported that Chinese models grew from making up about 1% of OpenRouter usage in 2024 to over 60% by May of 2026.
And just give some context for you listening, OpenRouter is a unified interface where developers can route their API calls to dozens of different models through a single endpoint.
Like a hub.
Yeah. So seeing usage flip from 1% to over 60% in a couple of years is a seismic indicator of where developers are voting with their code.
And they are clearly voting for capability paired with unbelievable cost efficiency. Let's look at the numbers. DeepSeek v3.2 is currently priced at an incredibly low 28 cents to 42 cents per million tokens.
Which is practically free.
Basically. Then you have Kimi K2.6, which is scoring an impressive 90.5% on the GPQA benchmark, and it only costs 95 cents per million tokens.
That's incredible.
And just to benchmark the economics of this, ZPU GLM 5.1 completed an artificial analysis 10 evaluation benchmark set for a total cost of $544.
Okay.
Running that exact same test suite on Claude cost $4,811.
Wow. That's almost a 10x difference.
Here's where it gets really interesting, though. I have to ask, is this just a massive loss leader strategy? Like, are these companies just dumping compute below cost to capture market share? Or are developers globally actually getting true frontier-level performance for pennies?
If we connect this to the bigger picture, it's actually both.
Hmm?
The benchmark data tells us it is unequivocally genuine capability, but the GPQA isn't a basic trivia test.
Right.
It's a benchmark designed specifically to test graduate-level reasoning in physics, biology, and chemistry. When you see a model like Kimi K2.6 scoring 90.5% on that test, it proves it's not just cheap, it's exceptionally smart. What we are witnessing is a fascinating competitive shift and really the rapid democratization of intelligence.
Because when high-tier AI costs a fraction of a cent per prompt, a developer in Nairobi or, a small logistics startup in São Paulo can suddenly afford to build complex agentic systems that run 234/7.
Exactly. Software that was economically locked behind a massive paywall just a year ago is now universally accessible.
It totally decentralizes the power of the technology. We're talking about millions of developers globally accessing this intelligence for pennies. But that intelligence doesn't live in the ether.
No, it does not.
It lives in massive, energy-hungry physical data centers. And when you look at the geopolitical briefings in our sources today, you realize just how incredibly vulnerable the physical supply chains powering that borderless AI actually are.
Yeah, that is the sobering reality check here. We've spent this whole time talking about a company burning $1.25 billion a month on computing power. That compute requires an incomprehensible amount of electricity, cooling infrastructure, and rare earth minerals. And while the software deploys globally in milliseconds, the physical realities of supply chains and energy markets remain incredibly fragile.
Absolutely. And just to be clear, as we go through these next few points, we are just factually reporting what is in our sources today. We aren't taking any sides or endorsing any viewpoints. We're just giving an impartial global snapshot to ground this digital boom in physical reality.
Right, because the global context matters deeply to this industry. In the Middle East, our sources note that Israeli strikes killed 14 people in Dir Kanon and Nar and another 5 near Nabati in southern Lebanon.
And this violence occurred despite a U.S.-brokered ceasefire extension through June.
Yes, and the direct macroeconomic result of this is that global energy markets are reacting. Oil prices have risen to $104.63 a barrel due to the persistent regional violence.
And when oil spikes to nearly $105 a barrel, the cost of running a gigawatt data center in Texas or Virginia feels that impact immediately.
It directly threatens those exact profit margins we were just discussing.
Right, and the instability isn't isolated. In Sudan, an armed drone struck a crowded market in West Kordofan, killing 28 people. Meanwhile, over in the Americas, the USS Nimitz carrier strike group has entered the southern Caribbean amid rising tensions with Venezuela.
We're also tracking severe disruptions to physical logistics. In Bolivia, 3-week-long protests in La Paz led by miners and the Workers' Central, who are demanding the president's resignation, are severely straining basic oxygen and medical supplies in the region.
It's a huge disruption.
And we even saw disruptions in Europe, where Lithuania briefly had to close Vilnius airport entirely following an air raid alert, though operations did eventually resume.
When you look at all of these events together, it really highlights the vulnerability of a physical layer. Infrastructure, whether it's humanitarian aid corridors and conflict zones, the global energy markets dictating oil prices, or the sprawling data centers and undersea cables powering the AI revolution, it always exists at the absolute mercy of real-world geopolitics.
It is a profound dichotomy. The digital boom we are tracking relies entirely on a physical world that is currently experiencing intense friction and fragmentation.
But despite that physical world fragility, the sheer computational power we unpacked earlier is beginning to yield fundamental breakthroughs that sort of transcend supply chains and economics entirely.
We are seeing AI move beyond the realm of business logistics, beyond chatbots and consumer tools, and directly into the realm of pure scientific discovery.
This is the part of today's stack of sources that just left me in genuine awe. OpenAI announced that one of its models has successfully disproved a central conjecture in discrete geometry.
It's amazing.
And I really want to emphasize how it did this. This was not an AI formatting a LaTeX paper or, crunching a massive spreadsheet to assist human researchers. The system generated a novel mathematical proof entirely on its own.
It literally traversed unmapped logical space without a human explicitly prompting each step. When AI can autonomously string together complex logical pathways to disprove a mathematical conjecture that has stood unresolved by human minds for decades, we are crossing a major threshold.
We really are.
It reinforces a theme of informed optimism, I think. Humanity isn't being replaced by this technology. We're being profoundly accelerated. The mathematician who spent years banging her head against that geometry conjecture isn't obsolete today.
No, not at all.
She just gets to start her next phase of work at a significantly higher, faster level of truth.
It's expanding the boundary of what we know. It's not about publishing a blog post to WordPress or categorizing your bank statements, as useful as those things are. It is literally about solving the mysteries of the universe.
Which brings us full circle to that $1.25 billion monthly compute bill.
Oh, right.
The reason these companies are spending billions and the reason they are reaching profitability is because the output of that compute is mathematically undeniable. It is generating net new knowledge.
So what does this all mean for you? We started today asking you to hold two contrasting realities: the massive cost of compute and the rapid path to profitability. We've seen how that infrastructure is becoming a global utility, dropping in cost by 10x a year, and how it all relies on a very fragile physical supply chain.
Yeah, a lot to take in.
But I want to leave you with a final thought to mull over. If an AI can now autonomously traverse logic to disprove decades-old mathematical conjectures, while the cost of accessing that intelligence drops to mere pennies, what happens when this level of graduate-level reasoning becomes as cheap and ubiquitous as the electricity in your wall? What impossible, stubborn problem in your field might just be a 28-cent API call away from being solved? Thank you for joining us on today's Deep Dive. Keep questioning and keep exploring.